Okay, I'm going to carry out some calculations here to find the relationship between two variables I've worked out from an experiment. Two variables that we're talking about here are x for extension of a spring, quite a long spring, and EP here, which is the potential energy. Now I've done 3 trials here. So the very first step I'm going to do with my graphics calculator here is I'm going to calculate the average of my trials. So I mean, calculating the averages should be a straightforward task here. I'm just going to put in the 3 trials and execute, get an answer and divide by the number of trials we had, and there we go. Answer there of 6.3. 6.3. While you've been waiting, I've just been doing the averages. Just noticed here in my data there's a point that kind of doesn't fit in with the others. If we look down here at extension 6, we can see that we have this number here, 170. That seems not to fit with the 2 other values. It's quite quite a distance out. So we're not going to include this in our data set here, so we're just going to add these 2 together and get the average. And of course, I don't really have to do that on the calculator. The average of 210 plus 214 is 212. Okay, we'll just average the last couple here. 290, 295 plus 290 gives us 292 roughly. And the average of these 3 here is 375. Right, so now I have 2 data sets here. So this is going to be my x value, and this is my y value. What I'm going to do now is I'm going to enter these values into my graphics calculator. So the first button we're going to press here is our menu button, and we're going to click on 2, so we go into stats and we can enter our data into this table. Now the x value goes on the left hand side here, so I'm going to put that in first. So we've got 6.3, execute, 23.3, execute, 53.3, execute, and so on. And I'll just go through and enter all of this data right now. Okay, so I've now calculated this square root of potential energy column, and what I'm going to go and do is put this back into my graphics calculator and we're going to plot it. So again, we're going to go to menu, we're going to go to stat, and we're going to replace the column, the x column that was that had EP. Now it's going to have the values from the square root of EP. So the first value here, 2.51, execute, then we have 4.83, execute, then 7.33, execute, 9.73, execute, 12.1, execute, 14.6, execute, 17.1, execute, and the last one, 19.5, execute. Now if I identified the first graph correctly, and it was indeed y is proportional to the square root of x relationship, This graph now, where I've plotted my y value against a squared root of my x, is going to give me a straight line, or a linear graph. There it is. Now notice the dots aren't absolutely perfect, but they give a very good approximation of a straight line. So what we're going to do now is press calculate, press x, because this is just going to be a straight x function for our graph, ax plus b, and we've got the values in the form of a graph equation here, where y, so let's write this down, y equals a value is 0.411, 0.411, x, which is x minus, because we have a negative value for b here, 1.3 times 10 to the negative 4. Okay, so let's just simplify that. This number here is, in all intensive purposes, it's a very, very small number, and we can just approximate our intercept here to 0. So what we really have is this equation here, y equals 0.411x. Okay, but this isn't in the form we want to have it. Now we have to substitute whatever our quantity was for y, which was x for extension. Okay, so x equals 0.411. Now we substitute our x value in here that we just used on this last graph. Now the x value on the last graph was actually the square root of EP. So here we put in the square root of EP. And this here is our graph equation. Okay, so this is our final graph equation, and this is what we're looking for. Thank you.